All right, we're going to start section 6.1, graphing quadratic functions. The definition of a quadratic function we have right here: f of x equals ax squared plus bx plus c. The first part here, this term right here is the ax term. So I suppose that's probably pretty important to have, I guess in your expression or in your function, because that's what makes it a quadratic. So that's kind of like your quadratic term. Here's your linear term, and this would be your constant term. Okay, so quadratic, linear, constant, and this is what makes it quadratic. All right, so our goal in this section is to be able to graph a quadratic function. Just a few terms that we're going to become familiar with over here is, well, the graph of a quadratic function is what we call a parabola, and then we're going to become familiar here after the first example, the axis of symmetry, and then the vertex of a parabola. So my goal in this first example here, I have f of x equals x squared plus 3x minus 1. I want to graph this. I want to graph it just using a table of values. So I really don't have no particular way of starting, except for just picking, a random set of values for my x column. So kind of make a table here. If you remember, f of x is just function notation. So that's similar to or equivalent to your y value. And then my input values for x, I'm just going to choose those randomly. So I'm going to start with -2, -1, 0, 1, and 2. See where that takes me. I'm going to plug those values in for x and see what my output value is. Plug -2 in. -2 squared is 4 plus 6, -6. So 4 plus -6 is -2. Minus 1 is -3. Plug -1 in, I get 1 plus a -3. It's -2. Minus 1 is -3. Do that right. Let's see here. 1. -2. Yeah. 4. 6. Yeah, I think that's right. So 0, I plug 0 in, and I'm getting -1. I plug 1 in, I get 1 plus 3 is 4, minus 1 is 3. I get 2, but 4, 6 is 10, I get 9. So see what happens when we graph this. Let's sketch a graph real quick. It's -2. -3. -1. -3. Alright, so kind of a brain fart here. So I plug -2 in, I get -3. I plug -1 in, I get -3. So those two end up being side by side. I get 0, -1. So at 0 I get -1. At 1 I get +3. So notice as the farther I go to the right here, I'm getting higher and higher. So I have at 1 I get +3, and then 2 I get 9. So 9's clear up here. I really don't need to sketch that, but so as you see on the right, a parabola is a U-shaped graph. Okay, so what I notice here is that this parabola is going to come down. I'm just going to kind of sketch this through here. And it's going to go through this point right here, and these 2 points that are side by side, it's going to end up bottoming out. So then I'm going to have a minimum, and it's going to come back up through this point, and it's going to come right back up. So it makes itself look like a U. So you have a U-shaped graph. All right, so that's what a parabola should look like in this particular case. Now there's ways they can actually make this more accurate, and we're going to get to that here in a second in our next example. But another couple things just to point out real quick is we should notice that parabola or U-shaped graph is symmetric. So what I mean by that is if I would put a dotted line right up the center of this parabola, I should be able to fold it over, and it should match up. Obviously my graph is a little crooked here. I was freehanding it and just a sketch for now. So, but it's symmetric, so I should be able to fold it on my dotted line, and it should line up. So some of these points that I have sketched on this side should be a mirror image to the other side, and I should be able to use that when I go to graph my quadratic functions. Alright, so this next example here, I have f of x equals x squared minus 4x plus 2. A couple shortcuts in here that makes this a little bit more accurate, and that's the kind of way I've been shown to graph quadratic functions. So the first thing when I look at this in standard form here, I look at my constant term. One of the things I should always notice or should always remember is that value there is always my y-intercept. So that should be always a point to where when you get done graphing it, I should make sure that my parabola crosses through the y value of 2. So on the y-axis. So that's my y-intercept right there. So that's just something to remember. Another thing is when I talk about the vertex, there's actually a formula to find the x value of the vertex, and it's kind of a familiar expression. It comes from the quadratic formula, but it's minus b over 2a, and I get the b and the a value from the standard form of a quadratic function. So that's just my x value of the vertex. So in this particular case over here, if I'm trying to find that x value of the vertex, I take the opposite of 4, which opposite of negative 4 is positive 4, and over 2 times a. Well, in this particular case, my a is 1, so 2 times a is just 2. When I simplify that, I just get 2. So my x value of my vertex is 2. Okay? Now, to figure out my y value, all I got to do is plug in 2 into the function and evaluate it. So I get 2 squared is 4, minus 8 is negative 4, plus 2 is negative 2. So I have a vertex here of 2, negative 2. Right? Now, I'm going to use that value to, that ordered pair to set up my table of values. I'm going to put 2, negative 2 in the middle, and in this particular case, I'm just going to use certain values to one side of it. What I mean by that is I'm just going to use 1 and 0. Okay, so I'm going to use 1 and 0. When I plug 1 in up here, I get 1 minus 4, which is negative 3, plus 2 is negative 1. When I plug 0 in, I get 0, 0, plus 2. When I graph those values, we should notice that all I'm graphing is like one part or one half of my parabola. And that's all I really need, though, because I said earlier that a parabola, a quadratic function, is symmetric. And so I should be able to fold it over or use that symmetric property to graph the other half. So 0, 2, negative 1, or 1, negative 1. I did that wrong. 0, 2. Better. 0, 2, 1, negative 1, 2, negative 2. So notice that my tail of my graph is coming down here to this point. I already know that this is my vertex. That's where it changes direction. So I'm going to come down here, it goes through this point, this point, this point. And then symmetrically, this point right here is, if I fold it over, if I go up through this line or axis of symmetry, it should be exactly 1 unit away as well. So I'm just going to straight across the line, I'm going to put a point there. And the same thing goes from this point. So I'm 2 points away from my line of symmetry. So I have a point here in this case. So the symmetry helps me graph my parabola. And that's just a little bit more accurate than what we did previously, just by using a table of values. So, and a little bit less work too, because all I really needed to do was plug in 3 points, or find 3 points, and then use the property of symmetry to graph the rest of it. I realize this is kind of off a little bit, but that's just freehand sketching. If you use a piece of graph paper, which I suggest that you do when you go to do some of the problems, you should have better luck with that. So, all right, before I give you the try this problems, I do have one more thing to talk about, and that's finding the max or minimum function, okay? The last couple of problems that we've done, I'm going to kind of do this off the side, our parabola has opened upward, kind of like this, or U-shaped graph has opened upward. And that's pretty much the case, a lot of times. But also, a graph or a parabola can open downward. So, and then the way that we determine this, and we can basically look at this by just looking at the function itself, okay? And that's when this case happens when my a value is greater than 1. Okay, so basically it's not negative. Okay, your coefficient here, right here, is always positive. Now, when your a value is negative, that's when this occurs. So when a is less than 1, then you have a situation where your parabola is upside down, or your U-shaped graph is upside down. Well, what that creates, in this particular case, if it's going upward like this, it creates a minimum, a min, or if it's going downward like this, then this creates a max. Okay, a lot of times we're asked in problems for those particular situations. What's my min of the function, or what's my maximum of the function? So that's what we're asked here in this example. And when we're asked that, you're asked to find the y value. Basically, you're trying to find the y value of the vertex right here. Okay, the y, you have your vertex, you have some x value, but then you have your y value, and that's either your min or your max in that particular case. Okay, so if all I'm asked here for this function is find the min, obviously, I should be able to recognize how this function is going to look. So it's gonna, if I have it in the right spot or whatnot, let's say it goes like that. I should know or realize that it opens downward. The parabola does. So I'm going to have a maximum here for a function. Well, how do I find that? Well, the first thing I need to do is I need to find the vertex. I need to find the x-coordinate, which is x equals minus b over 2a. Minus b is negative 2. 2a, 2 times negative 1 is negative 2. So we're getting 1. So my x value is 1. That's not my maximum. I need to plug that in then and find out what my out value is to get my maximum. So I plug 1 in, and I get what 1 squared is 1, negative 1 plus 2. I get negative 1 plus 2 here is 1, plus 3 is 4. So now what that means is my max is 4 for the function. All right? So that's how you find a max or a minimum of a quadratic function. All right, here's 3 try this problems. The first two says graph the quadratic functions f of x equals 2x squared plus 2x minus 1. Number 2, f of x equals negative x squared minus 4x minus 3. The third problem down here, it says find the max or minimum of f of x squared plus 3x minus 4.